thing when it comes to elasticity. Go on this side. When it goes to elasticity. With regard to elasticity, we got a couple different formulas here. So we've got the elasticity of demand, which is the percentage change in quantity demanded divided by the percentage change in price. You guys see that okay? Yeah, okay. And I feel like too, you can pin me, and then I feel like I'm the only one if that makes it larger on your screen when you're doing things. But with regard to the percentage change in quantity demanded divided by the percentage change in price, they're either going to do a couple different things. They might tell you just flat out what the percentage changes are. You know, that's the easiest thing. They might say like the percentage change in quantity has gone up by, like, you might say the percentage change in the quantity demanded has gone up by 5%. And then the percentage change in price has gone up by 10 or gone down, right, by 10%. And so that's just a matter of knowing, well, where do I place those, you know, with regard to the formula, right? 5 would go on top, 10 would go on the bottom. And so this would be a 0.5. That would be my answer. It doesn't matter that it is a positive or a negative. It's always going to be a negative because price and quantity go in opposite directions for the elasticity of demand. This is really about the number and where does it fall. And so in this case here, the elasticity of demand is less than 1. And so therefore it would be an inelastic demand, right? When we're looking at it there. If I had to say why, though, instead of just saying, well, the coefficient is less than 1, that's where I would talk about the relativeness of the percentage change in quantity demanded relative to the percentage change in price. When a good is inelastic, consumers are less responsive, and therefore the percentage change in price is greater than the percentage change in quantity demanded. I would always be going back to percentage change in price over percentage change in quantity demanded when I am talking about things. Okay, so that's what I'm doing with elasticity. Instead of telling you the exact percentage changes, they could give you like a formula, or not a formula, they could give you like a word problem. And they could say to you, and this is what's so hard when I'm just making these up on the fly, but they could say something like the quantity demanded changed from, 10 units to 8 units. Now, the quantity has gone down, so the price has to go up. The price, they might say, went from, $5 to, if this went down, the price has to go up, went up to $6. So this is where then I have to use that whole formula here. Now, I'm technically using the midpoint formula, right? And so this is where I have to say the change in quantity demanded, the new minus the original, which would be 8 minus 10. And I need to take the midpoint or the average of that, which would be 9, divided by the percentage change in price, which I have to go from the new, which is 6, minus the 5. Oh God, divided by the original, which is 5.5. And so that's where then I have to take that times, do I take it by 100? I think I do have to take them by 100, right? Times 100. And then what does that give me for my coefficient for the elasticity of demand? So I don't know if you guys have your calculators with you. Let's just try it and see how this all works. Well, 8 minus 10, that one's kind of easier. 8 minus 10, that is 2 over 9 divided by, oh yeah, because you do it by 100, but these cancel out. So that's why I was like, okay, that doesn't matter. And then you have 6 minus 5, which is 1 over 5.5. So now, if I take it here with my calculator, and I've got 2 divided by 9 is 0.2. And then I've got here 1 divided by 5.5 is 0.18. So 0.22 divided by 0.18. All right, I'm coming up with 1.22. What'd you guys come up with? Yeah, you guys are so fast. Okay, so that's where you get 1.22. And so now this here is telling me that that good is elastic. Why? Because the percentage change in quantity demanded is greater than the percentage change in price. You know, if that's what they're coming back to or asking me to talk about when I'm doing this. Does that make sense?
When you describe that, does it have to be like, do you have to use words, or can you just use like the greater or less than sign?
Do the greater or less than sign. Okay. Absolutely. In fact, to be honest, as a reader, I would totally appreciate that.
Okay.
Yeah, but either one would work, you know, when you're doing that. How about any other questions with regard to calculating elasticity? You know, the other thing is that I could have done, what a waste of time, you guys. If they didn't ask me, I just thought, okay, if they didn't ask me to calculate it, right? I should have done the total revenue test. Like, shame on me, right? Because with the total revenue test, when I'm looking at it, if I would have done this, and when I'm looking at it here, I'm just going to set it up here. You've got your price times your quantity gives you the total revenue. Can we see that on there? And so if my price went from 5 to 6 and my quantity went from 10 to 8, that's where I have it here, where it went from 50 to 48. Look at, okay, that was written horribly, sorry. Look at how much faster that was, right? My price went up from $5 to $6. My total revenue went down from 50 to 48. The math, I needed absolutely no calculator there. So if they give me this stuff and they just ask me, is the good elastic or inelastic or unit elastic, I'm going to do the total revenue test. Because in this case here, when there's an inverse relationship between price and total revenue, then that means that the good is elastic. I can still come back and obviously talk about the percentage change in quantity demanded is greater than the percentage change in price. But I don't have to do this stuff unless if they ask me to calculate it. So definitely read for elasticity. What did they ask me to do? Did they ask me to calculate elasticity, or did they ask me just to state what is elastic? Because what a difference, right? In how fast I can get her done and how easier it is mathematically to do it. Okay, the other thing is that they could ask me about the cross price elasticity of demand or the income elasticity of demand. And so that's where I would just think about or remember those when I'm talking about that. So for the cross price elasticity of demand, what am I talking about? Substitutes or complements?
Wait, sorry, could you restate that?
Cross price elasticity of demand. Am I talking about, I should say it better, sub complements or normal or inferior goods?
Oh, the substitutes and complements. Yeah, there's one or the other option, and I got just like, wait.
I asked it wrong. And so for that one, I'm talking about substitutes and complements. And for this one, it's all about a matter of positive or negative, right? And so that one, I'm not going to care about the absolute value. Notice here, I didn't like throw in the absolute value when I wrote the thing. It's not a do or die when they're asking you on the AP exam. Yes, would I care, or would I want to have everything in there? But that's not going to make or break you on the AP exam. Now, you got to make sure I don't put the negative sign in there, right? Because it's not about a negative or a positive for that. But it is when it comes to the cross price elasticity of demand. Would you like me to go over the cross price elasticity of demand and how that might be asked and what you would need to do for that? Or do you feel good about that? If you want me to go over it, give me a 1. If you are like, I am good with it, give me a 2. Okay, so you guys are good for passing on that. Okay, so remember with that, Rahil, welcome. If you want me to go over it, Rahil, just ask me to, and I will, because these girls don't care. They'll be fine. You just got to let me know.
Okay.
Okay. Okay. So that's what I would say about elasticity. Think about how great or the different amount of questions that they could ask with elasticity, like they could just give different numbers and they could make this 5 different versions on a test where everybody's got to do their own thing, And so that's where I think about too, how easy this would be to use on the AP exam, right? And so that's something to think about. You could do it regular, you could do cross price, you could do income elasticity of demand. And so this is something I would definitely want to be comfortable with. And again, it's coming back to percentage change in client demanded versus percentage change in price. That's what they're looking for when they're asking that question. That's my tagline, right? And I'm comparing it. And like you said, Maya, throw in the greater than or less than sign. Just know which one you're doing. And you should be good with that. I also last night started on that review document. I started doing like the AP formulas for micro. So if you did not see that, the link right now just has it for units 1 and 2, the different formulas that I thought about that go along with it. So it's something if you want to print out, before the AP exam, modify in any way, you can make a copy and do that. But hopefully that'll help you a little bit as we're going through with these different things. Okay. Units 1 and 2, I think the other one that's big is the utility maximization. How are you guys feeling about utility maximization? Would you like to do a practice problem with that? Yeah. Okay. Here's what I'm going to do for that. For the utility maximization, actually, I was just looking at this one. Let me see if this was one. Yeah. Okay. And the one that I gave you guys for practice, I'm not looking at you guys anymore. So please, now's where you got to talk if you want me to slow down or if you want me to do something else. So this one here is based, if you see the practice document that I have or something, this is where I'm getting the problem from, was last year's AP exam, okay? And so on this one here, they had 2 different goods that were being used. They had the quantity of water bottles. They had the marginal benefit of the water bottles. And then they also had just the quantity for good X and the marginal benefit. if you can't see something right now, I don't see what you guys see with my screen. So if you can't see something, let me know, because in my mind, you can see my whiteboard. Okay. For the quantity of water, just to give you the data, you've got 1, 2, 3, 4, and 5. You've got the marginal benefits that go along with it of 24, 18, 12, 6, and 3. Right? Then we've got this quantity of good X, and it's the same thing, 1, 2, 3, 4, and 5. And then they've got 24, so 18, 12, 6, and 3. Oh, same numbers. Isn't that interesting? What they tell you here is that the price of good X is 5. And I'm trying to see if they tell you what the price of the other one with it. The price of the bottled water, it says, is $3. Okay, so I'm gonna change it. Price of bottled water is $3. The price of the good X, because they change it, is $6. So let's start with utility maximization. If you are given this information, I'm coming back so I can at least see your faces. If you are given this information, what's the formula that we have to use for utility maximization? Rahil, do you remember the formula that we had to use for utility maximization with two goods?
Not really.
Rahil, that's painful. But good thing, Rahil, because I did put it on the formula sheet. So we do have it. So when we're talking about the utility maximization, we're looking here at, I'm going to write it down here. The marginal utility of X over the price of X needs to equal the marginal utility of Y over the price of Y. Okay, so that's our goal here, is to find it where they're equal to one another. And obviously we're dealing here with two different prices, and that's what makes it where you've got, there's no other way to do it than plug and chug and find out what it is. So when somebody tells me what the right answer is, we'll go from there, but I need your guys' help. What is the optimal, where you're maximizing your optimal amount? So what I'm doing is I'm going through each one and I'm giving my marginal utility per dollar, because I feel like that's the easiest way to be able to compare the units as I'm going through, right?
Is it 4 water bottles and 3 of good X?
Okay, 4 water bottles and 3 of good X. So when you have 4 water bottles, you have a marginal utility per dollar of 2, and then you have here where it is 2. So, oh, did I tell you how I didn't tell you how much they could spend, right? We gotta kind of know that in order to be able to do that, right? If she has a budget of $30, does that impact? Did you know that in advance? Were you looking at the problem? Is that how? Because she has a budget of 30. I have to tell you that, because otherwise I could find a bunch that are similar, right? Because you have it here where 4 and 4 could be a possible one that could have worked. So if she has a budget of $30, when I'm looking at this, if I'm buying 4 times 3 is 12, and I'm buying 3 times 6 is 18, that gives you your 30, right? So perfect. You've got 4 of the water bottles, and you have here 3 of good X. And that will satisfy spending all of the money, right? And being able to meet their optimal combination. The optimal combination of one good would be what formula? If they would have just asked you about what is the optimal combination of one good, how would you answer that? And it doesn't, not using the numbers or data, anything here. What's the formula? The optimal combination of one good is just the marginal utility equals the price. Like that's where we maximize because we have our diminishing marginal utility. This plays very much into what we're talking about here when we talk about these types of problems, right? And with each additional one that you are purchasing, your utility or satisfaction or value that you place on it becomes less and less. And so if the marginal utility here, or excuse me, if the price here is $3 and I have a marginal utility up here and that's not at $3, well, I haven't maximized my satisfaction because I'm still willing and able. I still have that consumer surplus, right? That goes along with that. And so I have to be at the point here where my marginal utility equals the dollar, because below that, it then is more expensive than what the value of it brings to you. That's like where you like physically get ill, you know, like you drank so much water, you're now like throwing up or peeing your pants, or I don't even know what you're doing, but you're doing something, right? That goes along with it. Okay, other questions that they can ask. They can ask you here about total benefit. So I think they even do it on this test. They ask you, what is the total benefit from purchasing 2 bottles of water and 1 unit of good X? And it says, show your work. So total benefit is the same as the summation of the marginals. And so the total benefit of 2 bottles of water would be me adding up the first marginal benefit plus the second marginal benefit. And so 4 and 8 is 12. So that's 32 would be my, 42 would be my answer there for the total benefit. I show my work. I show that 24 plus 18, and I say that's 32. You would still get full credit. If you set it up right, but you mathematically do not pull it off, you will still get full credit. And I mean, this is where we're shaking our head because we all know you have calculators, but it happens. And so don't worry about that as long as you're showing your work. Say you choose to just write 42 and you've got the right answer. You would not get credit for it at all because you didn't show your work. They're so strict about this. And so you have to show your work in order to get credit. If I were to put in the notation, is it a dollar sign? Like, what is it that I'm doing here in order to say the value of this? And remember, that's where it's those utils. What's the total benefit? The total benefit would be 42 utils. Now, what if the next one talks about consumer surplus? Assume that the price of a unit of good X is $5. So instead of it being $6, they have it now at 5. Calculate the total consumer surplus if they purchase 3 units of good X. I absolutely love this question. It's something that they haven't done a lot, to be honest with you. They've started to do it the past couple of years. And so students are still struggling with this. And so this one I always think is good if we can nail this one. So they said that the price of good X is $5. And they asked, what is the consumer surplus if she purchases bottles of water, right? What did I say? If she purchases 3 units of good X. Okay, So the formula that you're using for this is total benefit minus total cost. The other way that you could say it is total utility minus total cost. Either one is totally fine. Part of me really likes total benefit minus total cost just because that makes sense as we talk about some other units and it kind of goes with it. But you can use either one when you're doing that. So I'm just going to erase this one down here. And if we're talking about total benefit minus total cost, we said that they were doing 3 units. Is that right? This is so bad that I can't even remember this stuff. Yeah, 3 units of good X, and good X costs $5. So my total benefit of 3 units of good X is I have to add up these 3 units, right? So we know that 12 and 18, this is 30, plus another 24, that is going to be 54. And so I have a total benefit of 54. And I would show that. I would say, so let me do it the right way. I would say 12 plus 18 plus 24 and put those in parentheses. And that gives me 54 minus the total cost. And we said here they're buying 3 units and they each cost $5. So it's 54 minus 15. And so this one here for consumer surplus, my consumer surplus is 14 minus 5 is 9. 4 minus, and I've got my dollar sign, right? And I have $39. Do you guys agree with me on that? Okay. And so this is me showing my work, right? Do you have to write out this? No. But I like it because it just guides me as I'm going through and kind of drills it in my head exactly what I'm doing. But you've got to show this part here. You can't just come up with 54 either, you know, unless it had been in a previous problem where they asked you about it. But otherwise, you have to show how you came to that total benefit. They're going to be just so strict about that when we're talking about it. So I feel like utility maximization, this is a great one, you know, to use on the AP exam. Because again, I could just give you some different numbers here, but now I've got a lot of different versions flying of utility maximization. I could give this same chart and I could just change the prices, you know, and that's going to give different than optimal combinations that go along with it. I just want to look and see, was there anything else that they asked on here that they turned then this one? They said that if the price of the unit of good X drops down to $3, calculate the cross price elasticity of demand for water with respect to the price of good X and state whether the 2 goods are substitutes or complements. So for this one here, if you have it where the bottled water drops down to $3, I have to find my new optimal combination of goods, right? And so that's where you're looking then at the change that happens with regard to, did the goods go up or did the, did it go down with it? So when you're substituting and using it as complements. Would you like me to go through that problem with you, or do you feel like you're okay with, as we said before, we were okay with it? I'm more than happy to, you're okay? Okay. And so just see, though, how you can easily turn this into now an elasticity problem. That's the beauty of this game, right? We can connect things. And that's what they're doing this year. Again, it's going to be 2 questions. 1 question, you have 25 minutes, I think, to work on it, and then 5 minutes to upload. Does that sound right? And then the other one, I know you have 15 minutes and 5 minutes. So you have 20 minutes on the first one. What they said is that like these problems are like, they're just going to throw like random things in together. And so it might not even, it could be a whole new problem that could be part of the first one to make it longer. But just be prepared to hit a lot of different things as you're going through. Okay, so with unit 1 and 2, elasticity and utility maximization have a lot of math right? And a lot of different ways that you can put things together. When we think about other things that go, is there other topics of unit 1 or 2 that you would like me to go over specifically?
Oh wait, never mind. We're not graphing.
Huh?
I forgot we're not graphing.
Yeah, no, we're not graphing. So could you list on a piece of paper or somewhere, could you do the 5 determinants of demand and the 6 determinants of supply? Can you remember those? This should be like riding a bike. It should all come back. If you want, you can go back to what we had before with demand, where we did the hashtag iPet, right? And then for supply, we had our hashtag Tiger. So those, I think, are ways for you at least to start thinking about stuff. For demand, the hashtag is the number of consumers, right? This to me is like demographics, like different types of people. Millennials could be an example. Baby boomers, they're ones that have different demands that go along with things. Seasonal also falls into number of consumers and how they're using stuff. The I is for income, right? And this is when the income is changing. Remember that there's nothing about the price of the good that's changing, because when you have a change in price, that causes a change in quantity demanded, not demand. And so for this one here with income, you have normal and inferior goods. Remember, with the normal good, there's a positive relationship between income and demand. The P is the price of related good, and that's where you have the substitutes and the complements. And for me, like when I think about that, like for this one here, if I were to do, if the price of A goes up, remember that the quantity demanded for A goes down. And if the demand for B is going down, that means then that they're complements, right? Because they're used together. And so this is how, in my mind, and this is how I would explain it, right? You're using less of one, so you need less of the other, taking out our own bias of whether or not we would use them together. Future expectations, this is about price and availability. Do I think that the price is going to change in the future? Because I'll react now to that. This here, and like totally playing in the real world, when you think about like the stock market, like Rahel, you got to be going crazy. I remember how every class you would be checking stocks. Are you watching that all the time?
I was.
You what? You were. Are you now or no?
Sometimes, like not as often.
Well, it's a crazy time, you know, especially like you see things with oil and other stuff and how they're all just changing so much. And then my favorite, taste and preferences, right? Do you like it or don't you? Fads, research shows, those types of things fall under that one. Okay, and then with supply, number of suppliers, new industries come in and come out. Just think about like restaurants right now. They say that like 75 or 80% won't survive this whole pandemic. And so we could see like a huge decrease in the number of suppliers that go along with it. T would be for technology, right? We're going to be positive here, and technology is going to increase the supply curve. I, probably the one that's used the most, is the input price or the resource prices. I say use the most because you can do so much with like wages, you know, because that connects with the labor market. And so that's how you can see that connection a lot. Government regulations, taxes, quotas, subsidies. Taxes will always decrease supply. Subsidies will increase it. And then quotas will decrease supply. E is the expectations of the future, but on the producer side. I think that, to be honest with you, because they have to craft this so specific, they don't use these a lot because they're easy to confuse. And then The R would be the related prices. So again, you sell like sporting goods, I think is an easy one to say. You know, the price of one is changing. That might change your supply of the other. Okay, so I would have these obviously ready to go when I'm taking the AP exam, because you will be given like situational problems where if people make different choices based upon what's going on, what is that going to do to equilibrium price and quantity? Remember this, if two things happen, meaning that if there's a change in demand and supply, you're going to have something that's indeterminate. Indeterminate, if I have to explain it, means that it is dependent upon the magnitude of the shifts of the curve. So when I'm looking here and I'm looking at my supply and demand and looking at what we have here, and we'll just say good X, because I'm not creative, right? I've got my equilibrium price and quantity. If something happens where technology comes out for this product, well, that's going to increase the supply curve. If something happens where it's a new fad also that people like or want, that's going to increase demand. And so now the change that happens here leads it to where, yeah, the quantity for sure has gone up, but the price is dependent upon which one shifts more. And that's where I think like too, like, I don't know if you remember this, like I would say you could graph it or you could stack it. And I like to stack it because if I stack it and I have here an increase in supply, when you increase supply, price goes down and quantity goes up, right? When you increase demand, price goes up and quantity goes up. So I don't care which one you shift more, supply or demand. Quantity is going to increase no matter which ones get shifted more. But price is indeterminate because it is dependent upon which one is going to shift more. So again, they're not just going to ask you which is, what happens to price and quantity. They're going to ask you to explain. And that's where you can use that tagline about indeterminate, that it is dependent upon the magnitude of the shift of the two curves. And unless they specifically say one shifts more than another, you don't know that. So I think that's a great way, like to have students to be able to say it. Otherwise, if I had to say what happens, let's just say they just asked about an increase in demand. And like, how do I say that in my own words, that price and quantity goes up? Well, what happens when you have an increase in demand, and I feel like you can still see it when it's here. When you have an increase in demand, what this means is that people, consumers, are willing and able to buy more at a higher price. Because remember, the definition for demand is the willingness and ability to consume at a given price. That's what demand is. So what we're saying now is that they're willing and able to consume more at a higher price. If you look here at this, and if I look at my P1 and my P2, right? At this one here at P1, they're willing and able to consume that amount. But now with the demand curve over here, they're willing and able to consume more. So just being able to say things, so that way you show that you understand the concept. That's what I think it's going to be about this year when they're doing things. So if they say, why what happens to price and quantity, explain, I'm probably throwing in a determinant to show why it shifts. And then I can just finish it with they're willing and able to consume more at a higher price. That stuff I'd be thinking about for demand and supply. But remember here, the other thing is about ceilings and floors. So when I think about ceilings and floors, they can tell me, they could do this a couple ways. One, they could give me a graph and they could have it here, and we'll just go with our friend GoodX. GoodX is getting talked about a lot today. Okay. And so with that, we've got our demand, and they could have it supply, and they could tell me that the equilibrium price is $10, and they could tell me the equilibrium quantity is 120. They could write that out in a couple sentences. What am I going to do? I'm going to graph it real quick. So I've got it visually in front of me. Obviously, your labeling doesn't have to be perfect. It's painful for me to even say that, but they're not going to be looking at your graph. Okay. So then they could tell you that they put in a floor at $8. Calculate the surplus or shortage that happens. Or is there no change? Those would be the three ways they would say it, you know. Or they might say, does the quantity increase, decrease, or stay the same? Explain. If they put in a floor at $8, first off, a floor, define it in your head. A floor is where the government is saying you can't do a price below this amount. You can do something higher, but you can't do a price below this amount. If they put in a floor at $8, they're saying I can't go below $8, but I can still go to the equilibrium price. So quantity would not change because the floor is not binding. That's the term we use. It's non-binding, not binding. Either one will work. And then that's where I give the definition, you know, because they will choose to do it at $10 because that's the allocatively efficient amount. And ultimately would be the profit maximizing. So if they said, okay, instead they gave this scenario and they said they did a floor at $12, what happens? So at $12, and they would be very specific with their wording, you know, like as to what they want you to express. The thing is that if it's a graph and I've got all kinds of numbers down here, I can calculate my shortage or surplus that occurs here. So when I look at the graph, let's say that this hits it here at 100, and the quantity supplied goes up to 130. And if they ask what happens here, I'm going to answer with my buzzwords or the taglines that go with things. That first off, there's a surplus. There's a surplus because the quantity supplied is greater than the quantity demanded. And then if I'm asked to calculate it, my surplus is quantity supplied minus quantity demanded. The quantity supplied is 130. The quantity demanded at $12 is 100. And so therefore, I have a surplus of 30 units. I got to show my work and have all of that. Does this come in backwards to you guys when you're looking at this? Or does this come in? No, good. Because when I'm looking at myself, like I can see myself, it's backwards. Okay, so that's how I would explain that, right? A floor, know how to define it. A surplus, know how to calculate it. So easy to create a question. And then the trick is it binding or not? And if it's not binding, then it will work itself back to equilibrium because everything works out in Econville. And so we're all happy. Okay. And so that's something that I think is a good one for it. And then we talked also before about comparative advantage and being able to calculate the opportunity costs that go along with it. Would we like to do a practice one of those? Or do we feel okay about comparative advantage and how to figure out who has the comparative advantage? Just give me feedback.
Could we do terms of trade?
Yeah. So I think like what I want to do is I'm going to use one of the practice ones that I like put out there for you guys on that master review document, because I'm pretty sure I have the absolute and comparative advantage. Okay. And so again, I'm not seeing the screen because I'm looking at what I have here, just so you guys know that. So, okay, remember with comparative advantage, you're toast if you don't know if it's the input or the output method. So I need you to be good about that. Remember, it's the input method if the amount that they produce is held constant, like 1 unit of each. It is the output method if the resources, they do it in 1 day. You know, that's the type of stuff that we're talking about. I think I'm going to do an output method problem here. I'm doing the second one where you have country yellow and blue. I should have done maize and blue, let's be honest. That's what I wanted to do. So when you've got this here, you've got country yellow and country blue. They are doing consumer and capital goods. I'll be honest with you. I wrote this also for AP Macro. AP Micro would be more about like good A and good B, or shoes and robots. You know, they would be more specific because that's what they're talking about when they do things, or particular items. So for this one here, I have the numbers here of 40, 60. I think it's what they can do in 1 day. 120, and then this one is 360. So what I'm doing, remember, is first off, in order to figure out terms of trade, I've got to figure out my opportunity cost. So in order to do that for the output method, I need to take the number that's outside of the box. I need to take that number over in order to do this. And so 120 over 40 are 3 of the capital goods. 40 over 120 is 1/3 of the consumer goods. 360 over that is 6 of the capital goods. And this would be 1/6 of the consumer goods. My next thing is to figure out who has the comparative advantage. You could have it where somebody doesn't have a comparative advantage. It could be like 1 to 1, and they would easily do that to try to throw you off. And so go with how you solve things and answer it that way. That's what they're going to do. And so in this case here, 3 is less than 6. And so they have the comparative advantage. Why? Because the opportunity cost is lower. That's my rationale. 1/6 is less than 1/3. So what we know here is that country yellow is good at making consumer goods. So for every consumer good that they make, they have to get at least 3 of the capital goods. Why? Because otherwise the opportunity cost is larger than if they just made that consumer good themselves. It doesn't make sense to trade. Everybody wins from trade. And so they're going to do it if it benefits them. They'll do it even if it's just the 3, because they might be able to do better with things in the long run. And so even if at the time it's not so great, personally, the world is doing better because resources are being allocated more efficiently. So they're not going to give them more than 6 of the capital goods. So the terms of trade are what are the numbers that are here. You have to get at least 3 capital goods. They're not going to give you more than 6. For the capital goods, for everyone that is made, they have to get at least 1/6 of a consumer good. They're not going to give them more than 1/3 of a consumer good. And so that's where they may give you the terms of trade. And they may say, for every consumer good, there are 4 of the capital goods. And so then they could ask, well, what happens to yellow if they were to trade all of their consumer goods. Well, if they traded all 40, they would end up with 160 of the capital goods. And so that's where you would have here 0 of the consumer goods because they traded all of them. And they would have 4 times 40 was 160 of the capital goods. And that's how you can see things change, right? And as opposed to them only having 120 if they did it all by themselves. So that's how they've grown from 120 to 160. The other thing that they're very good at is they're very good at giving you one that's outside of the terms of trade. And so when a number falls outside of the terms of trade, somebody's going to win and somebody's going to lose. And so in this one here, if they were to say, let's say that they were to do one consumer good is traded for 2 capital goods. Well, if I flip that, then that means that 1 capital good is going to be worth 1/2 of a consumer good. So when you look at yellow here, yellow would be like, this is larger of an opportunity cost than if I made it myself. And so yellow would choose to not trade, or the best way to say it is produce domestically because it wouldn't be worth it to them. Blue would be all over this because they would get 1/2, which is much larger than their 1/6. So they got no issues with this trade. So they would be happy to do it. But yellow would not want to trade because the terms of trade would be outside of their amount. Does that make sense? I feel like they're not drawing PPCs, you know what I mean? Where you'd have to like draw, like, what would that change be? Where it would be the 4120, you know, like no longer are you then showing it shift out because it would be like 40 of the consumer and 120 like this. It now would look like that. You can't make more than the 40 on your own. And then this would be where it's 160. Remember this though, you guys, use numbers wherever you can. So like if they give you information and they're asking you things of what happens, don't just say it would increase. It would increase to 160, you know? So make sure that you're good about that. Are there any questions?
How would you do the input method differently?
Okay, so if it was the input method, when we're talking here, and to be honest with you, I can just use these numbers. But first off, it's going to be phrased differently. Instead of them saying that it takes 1 day to produce this, this would be the number of workers needed to produce 1 unit. Okay, you're only making 1 unit. Maybe they'll say you're making 100 units, you know, like I don't, you know, whatever they're choosing. But a lot of times they just do it on 1. If I'm doing things like with 100 units, I'm getting the opportunity cost here of 1 unit, and then you can multiply it, you know, like by that 100 if you have to finish an answer. To do the input method, you go into. So if I was to figure out what the opportunity cost is, I now have to take the 120 into 40. And so this would be 1/3 of the capital goods. So for every consumer good that is made, they have to give up 1/3 of the capital goods. For every capital good that is made, they have to give up 3, because 40 goes into 120, of the consumer goods. Okay? And then you do the same for the other. One second, my TV just turned on. And so that's how I'm able to figure out then the opportunity cost. 360 into that would be 1/6 of a capital good. And this would be 6 of the consumer goods, right? And I'm still looking at the same though, who has the least opportunity cost. That doesn't change. And so for this one here, they would be good at making the consumer goods and they would be good at making the capital goods. My terms of trade would be these if they were to ask for an input method problem. It's still the same numbers, right? And so I'm just, those would be my terms of trade. There was something I was going to say. Don't forget about absolute advantage. With the absolute advantage for the input method, it's who uses the least amount of workers. 40 is less than 60. And so therefore, yellow has the absolute advantage. If it was the output method, it would be who can make the most, right? I gotta flex my guns here. Who can make the most? So there's a lot that they can ask with comparative advantage. It doesn't get used a lot on micro like it does with macro, but it's there. You know, it's definitely, we're able to use this and connect it like with the PPC to show economic growth. That, you guys, is really units 1 and 2, I feel like, in going through the different components that go along with it. Any questions that you have? Anything additional that you would like me to go over? Okay. So the next round of stuff will be on units 3 and 4, which the majority of the test is usually about. And so will it play into that? I think for sure everybody will get a question on unit 3 or 4, you know, be it perfect competition or the imperfect competitions. I don't think that's going to change with regard to the FRQs. So we'll just have to see, you know, like with all of that. But units 1 and 2, I think, are pretty straightforward, right? And then we kind of build into that. So I think we're good here. I've recorded this. So if anybody wants to go back and look at it, you're more than happy. I will link it, I think, on this document, so that way it's there for anybody that would like to look at these different problems. Okay. And it helps coming in with questions too. So thank you, because that just helps me be able to focus on what you guys need. All right. Okay. Well, I hope that you guys have a good rest of the day. It's sunny out. So I think we all should try to find at least 10 or 15 minutes to get outside and try to enjoy the sunshine. Okay. All right. Have a good day, you guys.
Thank you.
All right, thank you.